Hello, this is Ms. Pedraza, and I am going to be reviewing how to go from names to formulas themselves. Now, the main thing to remember is that our periodic table is basically made up of mostly metals. And this little staircase right here is telling us anything to the left in general. Anything to the left is a metal, anything to the right is a non-metal. Now, you have to be careful with hydrogen because hydrogen is a nonmetal with metallic properties. What I would think what would be best for you to do is actually color coordinate your periodic tables so that you can distinguish which ones are your metals and which ones are your nonmetals, and also put the oxidation numbers on here. So let me review what I have on here. First, everything in hot pink is my metals. Anything in the blue are my transition metals. Now, I know tin and lead are not transition metals, but they're going to take on some of the rules from the transition metals. And then in green are your non-metals, which includes your hydrogen over here. Now, the oxidation number at the top, if you notice, the positives are my cations, which are my metals. The negatives are my anions, which are my nonmetals. Now these numbers, these oxidation numbers, are telling us which ones, how many electrons they're willing to transfer and how many electrons they're willing to obtain or share. Now the nonmetals right here, if you notice, I didn't put an oxidation number at the top, due to the fact that, these are your noble gases, which are already stable and they don't want to really do any type of reaction. So that's why they're kind of separated out. We're not really going to do any formulas with them at this moment. So just to keep this in mind, they don't like to react very well. Okay? Now, another thing that you have to put in mind is that if you have a metal and a nonmetal, that gives you your ionic compounds. Ionic compounds are the ones that you have a cation and anion. You have most of your rules for forming the formulas and actually writing are coming from the ionic. The covalent ones are two nonmetals, which are two anions put together, and those have a very simple, real simple rules to follow by. So I'm going to start off with the ionic compounds first. That way, you can get used to those rules, and then I'll end with the covalent compounds. Okay, let's get started. So the first one that I'm going to do is called aluminum fluoride. Your first question is aluminum a metal or a non-metal? Well, like I said, we're going to start off with ionic, but that's the first thing you want to ask yourself whenever you're doing something like this, writing a formula or writing a name, okay? I'm going to look to see where aluminum's at. I know it is a metal. Then second question would be, is it a transition metal? So if I look on the periodic table, aluminum is right here. It is not part of my transition metals. So I'm just going to simply say, okay, well, my aluminum has a +3 oxidation number. The second one is my fluoride, which fluorine is right here, and it has a -1 oxidation number. So what I'm going to do is I'm going to bring aluminum over here. I'm going to put the +3 above it. Okay, and then I'm going to put the fluorine with a -1. Now, what that does is that now it goes to my next step, which I'm going to say, are these the same number opposite charges? No, they're not. This is a +3, this is a -1. And that's the only thing we needed with those charges. So once we figure that one out, we get rid of the charge. Now we're left with these numbers. the superscript of the second one of fluorine is going to be the subscript of aluminum. And then the superscript of aluminum becomes the subscript of the fluorine. Now the rules say that if you have a 1, you don't have to write it, so that goes away. The reason being is that by writing the symbol itself, you're already saying you have one of them, or 1 mole of them. So your final answer or formula is going to be aluminum fluoride would be AlF subscript 3. All right, let's try this out again. Now, during this video, what you can do is actually pause it, answer it, and then go back to see if you got the correct answer. That's a good practice. All right, we're going to look at potassium permanganate. Potassium is an alkaline metal. It is a +1 oxidation number. Now notice that we end in ATE, permanganate. Anything that ends in ATE, ITE, will have a polyatomic ion, okay? So what we're going to do is I'm going to start off with the potassium and put potassium and my +1. And then I'm going to look for permanganate, and that's going to be on the back of your periodic table in the reference table that I gave you. We're going to look on the polyatomic ions. We're going to look for permanganate, which is right here. Permanganate is MnO4, and it's a -1 oxidation number. These little signs on the top right-hand corner, the charges, those are your oxidation numbers. So MnO4 is a -1. So what I'm going to do is I'm going to write out MnO4 -1. All right. Now once I do that, I'm going to look. Are these the same number opposite charges? Yes, they are. So what I'm going to do, they go away, and all you do is write the symbols side by side. So potassium permanganate is KMnO4, and that's it. All right, let's do the next one. Next one is called zinc chloride. Now again, your first question is this a metal? Once you say yes, let me show you where it's at. Zinc is right here, transition metal. That would be your next question. Is this a transition metal? Yes, it is. So this one's going to fluctuate a little bit. Now, typically transition metals will be given a Roman numeral. If they're not, then you're just going to guesstimate it being a +2. Now, let me go back in time, and let me put this here before we forget. +2. Go back in time and think why. Why would I say something like that? Now, there's a couple of them have their own set of rules, but for the most part, if you notice zinc, the last part would be 4s2, 3d10. Now, if you remember an electron configuration, the last S and the last following P will actually tell you what their valence electrons are going to be. Now, for metals, typically they're cations, that's why we say it's a plus. Since zinc has no P afterwards, but it has a 4s2, that 4s2 is what's telling us our oxidation number will be a +2, okay? Now the next thing is chlorine. Chlorine will be a -1. It's part of the halogens, so it's -1. So I bring my chlorine over here and put a -1. Now again, we're going to ask, are these the same number opposite charges? No, they're not. The charges go away. We don't need them anymore. Sorry about that. We don't need the charges anymore. The 1 from the chlorine becomes a subscript of the zinc. The 2 from the zinc becomes a subscript of the chlorine. Now, again, you don't have to write the 1 because once you write the symbol, it automatically says you have one of them. And then we end up with zinc chloride being ZnCl subscript 2. Okay? All right, let's do another one. Next one is going to be iron 3 oxide. We're going to say, okay, I know iron is a metal. Is it a non-metal? Is it a transition metal? Well, you know what? Since we have that 3 as a Roman numeral, we're going to say, yeah, more than likely it is a transition metal. And if we look on our periodic tables, iron is a transition metal, definitely. So what we do in this case, the Roman numeral is telling us what the oxidation number is going to be. So I can just say Fe plus 3. The only other one that I have to look for is oxide, which oxide is part of the oxygen family, a -2. So we're going to say O -2. All right. Is this the same number opposite charges? No, this is a +3. This is a -2. So the charges go away. Now the 2 from the oxygen becomes the subscript of the iron. The 3 from the iron becomes the subscript of the oxygen. And then we just say iron 3 oxide is actually Fe subscript 2 O3. Okay? Simple as that. Again, practice makes perfect, guys. It's all about practicing. Let's go on to the next one. Magnesium iodide. Is magnesium a metal? Yes, it is. What type of metal, or is it a transition metal, is what we need to find out next. So magnesium is right here. It is part of the alkaline earth family, which is a +2. So what I'm going to do is I'm going to put magnesium plus, and then the 2. I look for iodide, which is iodine, iodine is in the halogen family, which is a -1. So I put my iodine, -1. I'm going to look at that and say, okay, are these the same number opposite charges? No, this is a +2, this is a -1. So the charges go away, that's all we needed them for. Oops. The 1 from the iodine becomes the subscript of magnesium, and then the 2 from the magnesium becomes a subscript of iodine. Again, we don't have to write the 1 because once we write the symbol, we automatically say it's a 1, so it goes away. And we just say magnesium iodide is Mgi subscript 2. Okay? Like I said, your best bet is to pause, do it yourself, and then you check your answer just to make sure you're doing everything correctly. All right, next one, silver 1 iodide. So silver we know is a metal. Is it a transition metal? Well, I have a Roman numeral here, so more likely it is. And if you notice, yes, definitely it's part of your transition metals. It's right here. So we're going to say silver, and we're going to put the +1 because that's what the Roman numeral is telling me. The Roman numeral is telling you the oxidation numbers. And then we're looking on here, iodine, which is iodide is iodine, which is a halogen, and it is a -1 oxidation number. So what we do is we're going to bring our iodine over here, and we're going to put a -1. Next question. Are these the same number opposite charges? Yes, they are. So in this case, what they do is they both go away. It can be just written as AgI. So here's the thing. It doesn't matter what number it is. If they're the same number opposite charges, it's easy enough as just writing the symbols down. All right, let's go on to the next one. Mercury to bromide. So we know this is a metal. It has to be a transition metal since I have a Roman numeral, so let's just double check. Mercury is definitely a transition metal. It's right here. So what we're going to do is we're going to put down mercury. And it's telling me I have a +2 oxidation number. And then I'm going to look for bromide. Bromide is part of the halogens. It is a -1 oxidation number, so I'm going to put bromine down. And -1. So we're looking at this, sorry. Is this the same number opposite charges? No, this is a +2, this is a -1. So that makes the charges go away. And again, crisscross. So the one from the bromine becomes a subscript of the mercury. Oops. The 2 from the mercury becomes a subscript of the bromine. We don't have to write the 1, so that one goes away. And our final answer is going to be MgBr subscript 2 for mercury to bromide. All right. Next one. Barium phosphide. Is this a metal? Well, let's look at this. Barium's right here. It is part of the alkaline earth metals, the 2A. It is a +2 oxidation number, so I'm going to put down a +2 for barium. Phosphide, IDE, more likely off your periodic table, which is phosphorus, and it is a -3 oxidation number. Okay. Put my phosphorus. So again, rule of thumb, IDE typically is straight off the periodic table. All right. So, are they the same number opposite charges? This is a +2, -3. So that means the charges go away. The 3 from the phosphide becomes the subscript of the barium. The 2 from the barium becomes the subscript of the phosphide, phosphorus. All right. And we just end up saying that barium phosphide is Ba subscript 3, P subscript 2. All right, simple as that. Keep on going. Cadmium bromide. Is cadmium a metal? If so, is it a transition metal? So when we look for cadmium on our periodic table, we find it right here under the transition metals. So again, we're going to look for a Roman numeral. Wait a minute. I don't have a Roman numeral. So I'm going to automatically say, you know what? I'm going to put down a +2. And this is the basic of basics. So later on we will have exceptions to the rules, but for now, put down a +2. We look for bromide. It ends in IDE, so it's more likely off the periodic table. Bromide would be bromine, which is part of the halogens, which is a negative on oxidation number. So I'm going to get my bromine and put a -1. Are they the same number opposite charges? No, this is a +2, this is a -1. So the charges, we no longer need the charges, they go away. And we're left with these numbers. So the 1 from the bromine, the superscript from the bromine, becomes the subscript of the cadmium. The 2 from the cadmium becomes the subscript of the bromine. Now again, I don't have to write that 1 because once I write the symbol itself, it automatically says, you know what, I have one of them. So my final answer for cadmium bromide is CdBr subscript 2. Alright, I'm going to do 3 more. And the next one is going to be iron 2 phosphate. Well, we know that iron is Fe. And more than likely it is a transition metal because there's a Roman numeral here. So just to be on the safe side, I'm looking over here. Iron is right here. It is a transition metal. But then I'm stuck with, oh, let me put the 2 before I forget. I'm looking at this and it says phosphate. ATE, it is a polyatomic ion. So what we're going to do is we're going to get our chart that we received and we're going to look under the polyatomic ion list and look for phosphate, which is PO4 with a -3 charge. PO4 with a -3 charge. So we're going to get PO4. I'm going to put our -3 charge right here. Alright. Are they the same number opposite charges? No, they're not. So the charges go away. And we're going to crisscross it just like normal. The 3 from the phosphate becomes the subscript of the Fe. The superscript of the Fe becomes the subscript of the phosphate, but in this case, polyatomic ions, if there's more than one, will need parentheses. So you need to put it in parentheses first, and then you put the 2 on the outside. So your final answer is Fe subscript 3, PO4 in parentheses with a 2 on the outside. Now you have to put your polyatomic ions in parentheses because they think that they're their own element and they do not like to be separated out. That's why we put it in parentheses. Another reason is because if you do anything with the number on the inside or any of this, then you change the whole entire compound. Okay, so be careful with that. All the polyatomic ions, if there's more than one, put it in parentheses. All right. Here's another one. Mercury 2 phosphate. Again, ATE, polyatomic ion. Mercury is more likely a transition metal, and it's telling me it has a +2 oxidation number for sure. I'm going to look on my periodic table and notice that mercury definitely is a transition metal. And then I'm looking at phosphate. Again, anything that ends in ATE, ITE is definitely a polyatomic ion. And if you remember from us looking down at phosphate, it is a PO4 with a -3 oxidation number. So we're going to put PO4, -3. Are they the same number opposite charges? Nope. Charges go away. The 3 from the PO4 becomes the subscript of mercury. And the 2 from the mercury becomes a subscript of PO4, but we want to make sure our polyatomic ion is put in parentheses first. Oops, sorry. And then we put the 2 on the outside. So the formula is Hg subscript 3, parentheses PO4, with the 2 on the outside as the subscript. All right, last one. Get rid of this. Zinc 1 acetate. Zinc 1 means that I have a transition metal. So I'm going to put it down, but we need to double check just to be on the safe side. Zinc 1. And if I look on my lovely little periodic table here, zinc is definitely a transition metal, so yes, we're going to keep on doing it. And then it says acetate. ATE, polyatomic ion list. And the first one on the polyatomic ion list is this lovely thing. See how I have a comma here? That means I can write it either way. Typically they write it as C2H3O2 with a -1 oxidation number. So that's how I'm going to write it right now. C2H3O2. I would say it's a -1. Oops, I flipped it. Sorry. There we go. And we're going to look at this. Is this the same number opposite charges? Yes, it is. So that means I can get rid of this and just write it as ZnC2H3O2. All right. So again, if I move too quickly through this, I want you to pause, rewind, go back, and do it slowly. Pause in between the examples. That way you can try it out yourself and make sure that you're actually doing it correctly. If you need any other help with it, please come by and go in for tutoring. Well, thank you. That's it for today. I will record for the covalent molecular bonds in the next video. Goodbye.